Hello there, Mr. Sutton here, bringing you the IM3 5-1 Extra Practice Number 6 solutions on solving polynomials by factoring. For this one, there's a puzzle, so let's go ahead and see what that's all about. All right, here's the puzzle that goes with that extra practice. We're trying to solve the riddle, why are small balloons cheaper than large balloons? And the idea for this one is we've got a bunch of polynomials to factor. We actually just have to factor them. We don't have to solve anything. So we've got 1 through 6, and the answers for those we can choose from all of these down below. And then 7 through 8 or 7 through 12 has a different set of answers to choose from. Whichever answer you choose for the problem, you just have to put that letter underneath the problem number down in this box below. And just one thing to be aware of, some of these have multiple entries, so we just have to make sure that we put the letter in all the boxes where it belongs. So let's go ahead and give this a try. Here we go with problem number 1. For this one, even though we've got these b's going on, this is basically just a quadratic that we have to factor. So we've got, let's see, I'm looking for factors of 20 that add up to -9. So we've got 1 and 20 doesn't work, 2 and 10 doesn't work. How about 4 and 5? That would work if they were both negative. So I'm going to have a minus 4 and a minus 5. Only I need the b's in there as well. So let me make it a minus 4b and a minus 5b. And all of the problems that we're dealing with are going to have these a's and b's going on for the most part. So we're just going to be including b's with pretty much all of our answers. In this case, this matches up with, let's see here, which answer choice? This one right here, choice R. So we're going to put an R under spot number 1. And there's only one of those ones, so we move on to the next problem. On this next problem, I'm going to start by trying to take out a common factor since I notice I do not have a lead coefficient of 1. So it actually looks like I can take 3 out of all of these. So let me do that. That's going to be a squared plus 2ab minus 8b squared. And now I've got the 3 that I took down initially, and then I'm looking, since I have a lead coefficient of just 1 inside this parentheses, I'm just going to look for factors of -8 that add up to 2. So 1 and 8 doesn't work. The only other option is 2 and 4. -2 and +4 adds up to 2. So I'm going to have a minus 2b and a plus 4b. And I can find all of those things right here with n. So I'm going to put an n in spot 2. So here's an n going there. But now as I look, there's another spot 2 over here, so let me put an n there as well. And there's another 2 at the very end. So there we go, 3 n's for the price of 1. For this problem, I'm going to take out a common factor right away. These both have a 7 that they can give up. That leaves me with an a squared minus 4b squared. So I've got the 7 I can bring down. And then a squared minus 4b squared, that's an a squared minus b squared, general kind of b squared sort of situation, difference of 2 squares, where I can essentially square root both things and put a plus and minus with those square roots in parentheses. So the square root of a squared is, of course, just a. Square root of 4b squared is 2b, so I've got a plus 2b and a minus 2b. So we need a 7 and a plus and minus 2b. That's right here. That's an O. So that's going in spot 3. Next up, we've got number 4. Now this one, I'm not starting with a lead coefficient of 1, so let me take out common factors. The best I can do, unfortunately, is just 2. I can take a 4 out of 4 and 12, but that 14's messing me up. So let me take out a 2, and that's all I can take out. So that leaves me with a 2a squared plus 7ab plus 6b squared. Still, that's at least better than it was. So now for the stuff inside, there's no perfect square shortcuts that I can take. So I'm going to go with AC method. So we've got 2 times 6, giving me an AC value of 12. And then I can think of numbers that multiply to 12 and add up to 7. 1 and 12 doesn't work. 2 and 6 doesn't work. 3 and 4 does. Positive 3, positive 4. So I'm going to split up this 7ab into a 3ab plus 4ab. And nothing else changes, just making that middle term 2 terms instead. Now that I've got 4 terms inside, I can use a little grouping. So I've got the 2 I initially took out, And for these first two terms inside here now, I can take an a out of both of those. That leaves me with a 2a plus 3b. Next up, for these last two terms, those can both lose a 2 and a b. That leaves me with 2a plus 3b. So I've got the 2 I initially took out. I have the 2a plus 3b that I can take out of everything inside there now. And then I have my leftovers of a plus 2b. Let me see if I can find all of this stuff over on the left side. Looks like I've got all of it down here at the very end with this s item here. So 4 gets an s. We got an s over here, and there's 2 more 4s, so s here and another s there. All right, on to the next. For number 5, let me start by seeing if there's any common factors I can take out, because I noticed this is an a cubed, so this is not a quadratic. Luckily, these all have an a that they can give me. So I take out an a. That leaves me with an a squared minus 4ab, and then minus 21, and we're losing that a, so just 21b squared. So I have the a I took out. Inside here, lead coefficient of 1 next to the a squared. So I can just find factors of negative 21 that add up to negative 4. So 1 and 21 doesn't work. 3 and 7 works. Positive 7, or positive 3 rather, negative 7. So I have a plus 3b and a minus 7b. And I see all of that, let's see, where is it? Look at a that I took out. T is close, but it's the wrong factors in there. Right here we go. A. We have a minus 7b, a plus 3b. Same stuff, different order. So I'm putting an a next to spot number 5, and there's only one of those right here. On this problem, we've got an a cubed b minus ab cubed. Now I can take out an a, since they all have at least a to the first power, and also a b, since they have a b to the first power. Dividing by that, we have a squared, and the b is going away completely there. For the next term, the a is going away, and then b cubed becomes b squared. So I've got the ab that I can just drop down. Now, a squared minus b squared, that is literally one of our shortcuts. We just split that up into a plus b, a minus b. So all those a's and b's, I see all of that. Where do I see that? It's got to be around here somewhere. We have AB, A plus B, A minus B. There it is, hiding in the middle with H. So H is going to be spot 6, and there's only one of those. Problem. Let's start by trying to take out some common factors. So I see these are all even numbers, so I can take out a 2. And I see they also all have at least an x to the first power. So I can take out a 2 and an x. That leaves me with an x to the second power, minus this will be 6, and then we have an x and a y. And then we have minus 7, and then the x's are gone, so it's just going to be 7y squared. All right, so let's take a look at the stuff inside. I have a lead coefficient inside this parentheses of an invisible 1 here. So that means that I can just think of factors that multiply to negative 7 and add up to negative 6. So that's going to be, let me think here, positive 1 and negative 7. So I can rewrite this as x plus 1y and then x minus 7y. And let's see if I can find that over here on the left. So I need a 2x on the outside. Let's see here. There's a 2x, but I don't have the same stuff in the parentheses. Down here we have x minus 7y and x plus y, so that's what we need. So we're going to put an I then in spot 7. There's a 7 right here, and also actually another one over here. For this problem, let me see if I can take out any common factors. So taking a look, I see that these each have an x in them, so I can take at least an x out, and I think that's it. They don't all have y's, and 9, 6, and 1 can't do anything with that. So we end up, if we take out that x, with 9x squared minus 6xy, and then plus just y squared. The x's are gone. We can bring down that x, and now the stuff inside, I notice that I have two perfect squares, 9x squared and y squared, so I'm thinking I can use this shortcut over here, perfect square sandwich shortcut. So let's square root that 9x squared. That'll give us 3x. The square root of y squared is just y. Since my middle term is negative, I'm going to make this a minus y, all these things squared. And then if I multiply 3x and negative y together and double that, I'm going to get negative 6xy, which is what I wanted to get there. So that actually does work out. All right, well, let me look for my answer then. I can see that pretty quickly. It's the only one with a squared parentheses right here. That's going to be a B going in spot 8. For number 9, I noticed that all of these terms have a 5 that can be taken out of them. They're divisible by 5, and that's it. The x's, there's only 2 of them in those first 2 terms, and for y's, I don't have a y in every single term either. So all I can do is take out a 5. That leaves me with 3x squared plus, this will be 7xy minus 10y squared. And there's no shortcuts I can take with the stuff inside this parentheses. I'm going to have to go to my AC method on this one. So we have 3 times negative 10 for an AC value of negative 30. So I need factors of negative 30 that add up to 7. 1 and 30 doesn't work, 2 and 15 doesn't work, 3 and 10 works if I do negative 3 and positive 10. So I'm going to split this 7xy up into a negative 3xy plus 10xy. And everything else is exactly the same. Now that I have 4 terms inside here, I can use some grouping. So I bring down that 5 that I took out in the beginning, don't want to lose that. And now for my first 2 terms, I can take a 3 and an x out of those, leaving me with an x minus y. For the next terms, I can take out a 10 and a y, leaving me with an x minus y. All right, the 5 that initially came out is still there. I also have an x minus y that I can take out of everything, and a 3x plus 10y that also comes out. So I need a 5, I need a x minus y, I also need a 3x plus 10y. I see all of that actually on the very first answer choice up there. So spot 9 is going to get an F right there. For number 10, let's look for some common factors. I can't do anything for the coefficients, but for the variables, these all have at least an x squared in them. Not y's, but just x's. So we can take out an x squared, leaving me with x squared, plus this will be 12xy, and over here the x squared's gone completely, so 35y squared. That x squared can come down again, and now I just have a lead term of coefficient of 1 inside this parentheses, so I can think of factors of 35 that add up to 12. 1 and 35, nope. The only other option really is 5 and 7, which works. So I can split this up into x plus 5xy, and then, or 5y rather, and then we'll have x plus 7y. And all of that is going to be right here kind of in the middle with a t. So that's going to go on spot 10. We have a 10 right here, t there, and also another one at the very end over here. For number 11, looking for common factors, 15, negative 27, and 6. Those are all divisible by 3, so I can take at least a 3 out, and an x squared as well, because these all have at least an x squared. So that'll give me 5x squared for that first term, minus, this will be, let's see, 9 and xy. Over here we'll have 2, the x squareds are gone, so we still have that y squared. 3x squared can come down in a minute, but the stuff inside here, there's no shortcuts I can use, so I'm going to have to go with AC method. I have 5 times negative 2, an AC value of negative 10. So I need factors of negative 10 that add up to negative 9. That's not too hard. 1 and 10 works. Positive 1, negative 10. So I'm going to split up this negative 9xy into a plus 1xy minus 10xy. And now I can do some grouping. The 3x squared came out before, and it's still there. For the first 2 terms inside this big parentheses, I can take out just an x, leaving me with a 5x plus y. For the next 2 terms, I can take out a negative 2 and also a y. So that leaves me with a positive 5x. And over here, this is going to be a positive, let's see, is it xy? No, just a positive y, right? Because we're dividing by 2, we're dividing away one of those y's. Yep, just plus y. So we have the 3x squared still there, 5x plus y is coming out as well, and then x minus 2y is going in, and 3x squared and all the rest of that is right here with e, so 11 gets an e. Now there's a lot of 11s. We've got one here, 2 over here, and there's another one over here. So 5 different blanks filled in with that one problem. Here we go, last problem. So for this one, common factors, 8 and 50 are both even, so I can take out a 2. They both have at least an x to the first, so I'll take that out. And they both have at least y to the first, so let me take that out. So taking all of that out from my first one, we have a 4x squared. The y's cancel completely. For the next one, 50 over 2 is 25, so minus 25. X's are gone. Y cubed over y is y squared. I can bring down my 2xy again. Now the stuff in here, we've got a perfect square minus another perfect square, difference of squares. So that's an a squared minus b squared kind of shortcut situation. The square root of 4x squared is going to be 2x. Square root of 25y squared is 5y. So 2x plus 5y, 2x minus 5y. And I see all of that right here. It's the only one with a 2xy in the beginning. So that's going to be an L going in spot 12, so right there, and our final blank right there. Now that we've filled in all the letters, we have to kind of decipher this to figure out what's the answer to our riddle, which again was, why are small balloons cheaper than large balloons? So let's see, we got THE, that would be the, but there's a little bit more there, so I think this is actually the word theirs, and maybe an apostrophe in there, just to use proper English grammar. And then BEEN, that's Ben. LESSINF, I think just less. And then this is all one big word over here, inflation. Why are small balloons cheaper than large balloons? There's been less inflation. Okay, like blowing up balloons and blowing up the prices of balloons. Cool. Till next time, Mr. Sutton, signing off.